Hi, my name is Patrick Reagan. Part 4, Load Balancers, VPN, and Wireless Controllers with Network Applications and Functions continues the discussion of switches, routers, and firewalls from the last video. This video discusses load balancers, wireless controllers, content delivery network, virtual private network or VPN, quality of service or QoS, and time to live. A load balancer is a device or software application that distributes network or application traffic across multiple servers. The primary purpose of a load balancer is to ensure that no single server becomes overwhelmed with too much traffic, thereby optimizing resource use, maximizing throughput, minimizing response time, and avoiding overload of any single resource. Load balancers can also provide fault tolerance and high availability by monitoring server availability and health and removes unresponsive servers from the pool. When a back-end system fails unexpectedly, the load balancer can redirect traffic to healthy servers, minimizing service disruption. It allows for scalability by adding more servers to handle increased traffic. Some can cache and compress data to optimize performance. Some can provide SSL termination, which offloads the SSL decryption from the back-end servers. Some can include features like distributed denial of service protection and web application firewall. Many load balancers support session persistence, aka sticky sessions, to ensure users stay connected to the same server throughout their session, which is crucial for maintaining stateful interaction. A virtual IP address, or VIP, is an IP address assigned to the load balancer that acts as a single destination for incoming traffic. The load balancer then distributes traffic to the backend servers while presenting a single IP address to the clients. This configuration enhances availability and load distribution while ensuring users interact with a unified entry point. Types of load balancers include hardware load balancers, which are physical devices that handle load balancing functions. Examples would be the F5 Networks Beak IP, Citrix ADC, formerly known as NetScaler, and A10 Networks. Software load balancers are applications that run on standard hardware or virtual machines to perform load balancing. Examples include HA Proxy, NGINX, Apache HTTP Server with Mod Proxy, and Microsoft IIS. Cloud-based load balancers are load balancing services provided by cloud providers. Examples include Amazon's Web Services, Elastic Load Balancing, Microsoft Azure Load Balancer, and Google Cloud Load Balancing. Load balancing algorithms include round robin, which distributes requests sequentially across the servers in the pool. It is simple and effective with similar capacities. Least connection sends requests to the server with the fewest active connections. It is useful for servers with varying capacity. The least response time directs traffic to the server with the lowest response time. It ensures quick handling of requests. IP hash distributes requests based on the client's IP address. It ensures that the client consistently connects to the same server. Weighted round robin assigns a weight to each server based on capacity, distributing requests accordingly. It allows for a proportional distribution of traffic based on server capability. A virtual private network, or VPN, is a technology that creates a secure, encrypted connection between a user's device and a remote server, or between two sites over the internet. Because the internet is considered an insecure medium, encryption must be used to secure the data. A VPN creates a secure tunnel where the data is encapsulated or enclosed in VPN packets and sent over an insecure network such as the internet. This encrypted tunnel protects data from eavesdropping, hacking, and surveillance, making online activities more private and secure. Today, it is very common for an organization to use Remote Access Server, or VPN Concentrator, which enables users to connect remotely using various protocols and connection types. Remote Access Server, or RAS, is a type of server that provides services to remotely connected users over a network or the internet. A VPN concentrator, usually used by larger companies, is a hardware device that creates and manages VPN connections. By connecting to a RAS or VPN concentrator over the internet, users can connect to their organization's network so they can access data files, read emails, and access other applications just as if they were sitting at work. Uses of a VPN include encryption, whereas a VPN encrypts your internet traffic, preventing third parties like hackers, ISPs, or governments from intercepting your data. IP masking is when your real IP address is hidden and websites see VPN servers' IP instead, improving privacy. Bypassing restrictions is when the VPNs can help access geo-restricted content or bypass network censorship by routing traffic through different locations. Secure remote access is when organizations use VPNs to allow employees to securely connect to internal systems from outside the office. RAS and VPN concentrator will be placed in a screen subnet or DMZ so they can be accessed from a public address over the internet. VPN concentrators are often integrated into a firewall. In addition, there are many deployment options, including specialized cryptographic hardware and software-based options. The clients could use proprietary software or use the software that's built into the operating system to connect to the RAS server or VPN concentrator. A wireless access point, or AP, is a networking device that allows wireless devices like smartphones, laptops, and tablets to connect to a wired network, essentially acting as a hub that enables them to access the internet by bridging the gap between wireless and wired connections using Wi-Fi technology. It's a central point for wireless communications within a local area network or LAN. It typically connects to a router or a network switch using an Ethernet cable, which will allow internet access through the wired network. For larger areas, organizations may need to install multiple wireless access points to provide full coverage. These devices would typically be managed with a wireless controller or cloud controller, or would be deployed as part of a mesh architecture where the mesh nodes would connect to the root node that acts as a gateway for internet access. Autonomous APs have their own management interfaces and must be individually configured. A lightweight access point is an AP that does not operate independently. Instead, it relies on a centralized wireless controller to handle configuration, security, and management functions. A wireless LAN controller, or WLC, is a device that manages and optimizes wireless networks. It's essential for maintaining robust and scalable wireless networks, and it can help minimize traffic flow issues and bottlenecks as the network grows. It's a key component of networking, especially for large-scale or distributed networks. The wireless LAN controller provides centralized management by managing multiple access points in a network, simplifying administration. It improves network performance by automating tasks like load balancing and firmware updates to improve network efficiency. It ensures security by helping detecting and neutralizing threats based on user ID and location. Reduces downtime by helping maximize uptime and availability by allowing network updates to be deployed without going offline. The WLC is usually located at the data center where all the wireless APs on the network connect to it. Mesh network, Wi-Fi, is a system that uses multiple devices to create a single network that covers a large area. It's a good option for large homes and businesses, which help provide better coverage over a wider space and will help prevent Wi-Fi dead spots. A mesh network consists of a router and one or more mesh satellites which are placed around your home or office to create overlapping coverage. Connected devices automatically connect to the nearest router or satellite with the strongest signal. Data hops from one device to another until it reaches its destination. A wireless router is a device that not only provides wireless access like an AP, but also manages network traffic and acts as a gateway to the internet, typically including features like firewalls, DHCP and DNS services, and network address translation, or NAT. Wireless routers are commonly used in homes and small offices to provide internet access to various devices like laptops, smartphones, and tablets, and typically includes Ethernet ports for connecting wired devices like desktop computers with a twisted pair Ethernet cable with an RJ45 connector. With the Part 3, Basic Network and Hardware video, we started with the wireless access point. For smaller offices, a single wireless access point to allow users to move within the office. The wireless access point is connected via cable to the switch. However, if you have a large number of users and the users are spread out over a large area, you should consider installing multiple wireless access points, which will be configured and controlled by a wireless controller. The wireless access points are connected via cable to the switch. In a data center, we have the edge router, firewall, and switch. The servers have two network adapters. One connects to the data network, and the other connects to the storage network. The storage network is its own dedicated network. However, if we add the load balancer and VPN concentrator, you should place them in the DMZ or screen subnet. The load balancer distributes incoming web applications across multiple servers to ensure that no single server becomes overwhelmed with too much traffic and to redirect traffic from any web server that is not responding. Since the web servers are public-facing, which means they're being accessed from external users, they are in the DMZ or screen network so that different firewalls and firewalls can be applied. The database server can be used by the web servers. The firewall will have rules that only web servers can reach the database server and all other external traffic is blocked. For the VPN concentrator, users will use a client VPN to connect to the VPN concentrator. Since the users are coming from the internet, they'll be routed through the firewall to the VPN concentrator. After they connect to the VPN concentrator, they'll then go back through the firewall to access internal resources. A content delivery network, or CDN, is a geographical distributed group of servers that cache content close to end users. A CDN allows for quick transfer of assets needed for loading internet content, including HTML pages, JavaScript files, style sheets, images, and videos. The popularity of CDN services continues to grow, and today, the majority of web traffic is served through CDNs, including traffic from major sites like Facebook, Netflix, and Amazon. While a CDN does not host content and can't replace the need for proper web hosting, it does help with cache content at the network edge, which improves website performance. Quality of service, or QoS, refers to the ability to provide different priority levels to different types of network traffic, ensuring the performance of critical applications, data flows, and users. QoS mechanisms manage network resources by controlling and prioritizing traffic, which helps to meet the service requirements of various applications, such as latency-sensitive video conferencing or bandwidth-intensive file transfers. QoS is found on routers, switches, wireless access points, firewalls, load balancers, WAN optimization devices, VPN gateways, and IP telephone systems. Features of quality of service include traffic prioritization, which classifies and prioritizes network traffic based on predefined policies that ensures that high priority traffic such as voice and video get preferential treatment over lower priority traffic such as file downloads. Bandwidth management allocates and manages bandwidth to ensure the critical applications have the necessary resources, which prevents network congestion and ensures efficient use of available bandwidth. Latency and jitter control minimizes latency or delay, and jitter, which is variation in delay for time-sensitive applications, which ensures smooth and uninterrupted delivery of real-time services like VoIP and streaming media. Packet loss reduction implements mechanisms to reduce packet loss, ensuring data integrity and application performance, which is essential for applications requiring high data accuracy, such as video conferencing and online gaming. Traffic shaping and policing includes traffic shaping, which smooths out bursts of traffic to conform to desired traffic profile, which drops or marks packets that exceed defined bandwidth limits to enforce compliance with traffic policies. Time to live, or TTL, is a value in the header of IP packets that determines the lifespan of a packet. It prevents packets from circulating indefinitely in the network. Each time a packet passes through a router, the TTL value is decremented by 1. When the TTL value reaches 0, the packet is discarded by the router and an Internet Control Message Protocol, or ICMP, time exceeded message is sent back to the sender. Note, time to live is used in many network implementations and mechanisms. For example, DNS records have a TTL which specifies how long a record will remain in a system's cache before it will query the DNS server again to look up a DNS record and its value. Question: you just installed an application across 3 different servers. You need all requests to the application are spread evenly across the 3 servers. What should you implement? Answer: load balancer. Question: you have 2 servers at geographic locations to provide fault tolerance and high performance while appearing as one URL to users. Which of the following should the administrator implement? Answer: load balancing. Question: you're looking for a solution that can reduce the occurrence of customers receiving errors from back-end infrastructures when systems go offline unexpectedly. The security architecture would like this solution to help maintain session persistence. Which of the following would best meet the requirements? Answer: load balancer. Question: you installed a new web server, which will help with the resource exhaustion of another server. Which of the following algorithms should the administrator use to split the number of connections on each server in half? Answer: round robin. Question: to increase speed and availability, a high traffic web application was split into 3 servers recently and moved behind a load balancer. Which of the following should be configured on the load balancer to allow for a single destination? Answer: VIP. Question: which of the following devices will be used to manage a corporate wireless LAN? Answer: a wireless controller. Question: which of the following devices is used to configure and centrally manage access points installed at different locations? Answer: wireless controller. Question: you're planning to refresh your wireless network. You have 50 autonomous APs, and you will add 30 additional APs in the near future. The requirements state that the chosen solution should significantly decrease the management overhead of the current wireless network. Which of the following should the vendors recommend in response to the quote request? Answer: the use of lightweight APs with a wireless controller. Question: an IT organization needs to optimize speeds for global content distribution and wants to reduce latency and high-density user locations. What would you recommend? Answer: content delivery network. Question: which of the following functions is used to prioritize network traffic based on the type of traffic? Answer: QoS, or quality of service. Question: which of the following is used to stage copies of a website closer to geographically dispersed users? Answer: CDN. For more information, visit these sites. In summary, a load balancer is a device or software application that distributes network or application traffic across multiple servers. Load balancers can also provide fault tolerance and high availability by monitoring server availability and health and remove unresponsive servers from the pool. A virtual IP address, or VIP, is an IP address assigned to the load balancer that acts as a single destination for incoming traffic. A virtual private network, or VPN, is a technology that creates a secure, encrypted connection between a user's device and a remote server or between two sites over the internet. Autonomous APs have their own management interfaces and must be individually configured, and a lightweight access point is an AP that does not operate independently. A wireless LAN controller, or WLC, is a device that manages and optimizes wireless networks. A content delivery network, or CDN, is a geographical distributed group of servers that caches content close to end users. Quality of service, or QoS, refers to the ability to provide different priority levels to different types of network traffic, ensuring the performance of critical applications, data flows, and users. Time to live, or TTL, is the value in the header of IP packets that determines the lifespan of the packet. Thank you for watching this video. The next video will be Basic Networking Hardware, Part 5, Proxy and NAT. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.